All right, good afternoon or good morning, depending on when you're looking at this. We are going to finish up our notes on transformations today. The final transformation that we're going to talk about is dilation. This is a transformation in which the geometric figure is resized by a common value called a scale factor. Like rotations, dilations are also applied to a fixed point called the center of dilation, basically the center of the figure. And dilations do not slide, they do not flip, and they do not turn. So they are just either getting bigger or smaller. The scale factor will tell you whether it's getting bigger or smaller. If the scale factor is a whole number, that means it's getting bigger. If it is a fraction less than 1, then that is going to mean that it is getting smaller. For example, number 1, letter A, if you look at it, is the exact same shape. The size is different. So from image 1 to image 2, this would be a dilation. And it is getting smaller. Now, I don't know what the actual scale factor is because I don't know the original size compared to the new size, but it looks about half the size, maybe even a third of that size. When we look at letter B here, image 1 to image 2, it's the same shape, same size, the location is different. So this is not a dilation. And again, that is because it's the same shape and same size. Now, if we look at image 1, it's like the red cross symbol. So from image 1 to image 2, we see that from image 1 to image 2, it is getting bigger. It's still the same shape, but a different size. So in this case, this would be a dilation. And if you have ever heard of the word dilation, when you go to the eye doctor and they put those drops in your eyes and your pupils get bigger, that's a dilation. So your pupils are getting bigger. Our pupils actually dilate. So the brighter it is outside, the smaller our pupil opening is because we don't need as much light. If there's plenty out there, the darker it is, the more that our pupil needs to look bigger so that it allows more light to filter in so that we can see. So two geometric figures are similar when we are talking about dilations. The figures are congruent and the sides of the figures are proportional. So the sides themselves are going to be different lengths, but they're going to be proportional. Same thing when we talk about the shape, though. It's going to be the same shape, it's just the angles would be the same measurement. So two items that are proportional are if they divide to the exact same common ratio, or in this case, we're going to be talking about scale factors. So a 6 to 4, meaning one had 6 inches and the other one had 4 inches, that would simplify down to a 3 to 2 or a 1.5, which we know that 3 over 2 is a fraction, but that would still be a scale factor of getting bigger because 3 over 2 is the same as 1.5, so that is greater than 1. So does applying a dilation to a prime image produce a congruent final image? What about a similar image? It does not produce congruent, it does compute similar. And the reason for that is because it's not the same size and same shape. It's just the same shape with same angle measurements that are proportional to one another. All right, here we have dilations. We're going to multiply the coordinates of each ordered pair by the scale factor to perform the dilation. So I'm going to go ahead and graph the ordered pair 2, 2, 0, 4, and negative 2, positive 2. So 2, 2, and then 0, 4, it's going to be right here, and negative 2, positive 2. Okay, so when we create this, this is going to be a three-sided figure, also known as a triangle. So there's our triangle. It says dilate the point 2, 2 by a scale factor of 2. So sorry about that. When we dilate the 2, 2 by a scale factor of 2, all we are going to do is multiply the coordinates. So what I'm going to do is I'm going to take 2 and multiply it by 2, which gives me 4, and 2 by 2 gives me 4. So my new ordered pair now is 4, 4. So instead of 2, 2, I now have 4, 4. All right. We're going to do that same thing with 0, 4. So 0 times 2 is still going to give us 0. So unfortunately, nothing changed there. And when we take 4 and we multiply it by 2, that now gives us 8. So our new ordered pair is 0, 8. So we are going to be right here. And then our last ordered pair, we have -2, +2, and we're going to multiply it by a scale factor of 2. So -2 times 2 is going to give us -4. And our positive value of 2 multiplied by 2 is going to give us +4. Oops, I keep putting that. All right, so our new ordered pair now is -4, +4. So -4, left 4, up 4. And this is now our new triangular shape. So if you notice, it has gotten bigger. It is 2 times this size. That's what the scale factor was in this case. Okay, so how does the image from the previous activity change if the scale factor was 1/2 instead of 2? Well, the image would be smaller, or half the size. Half the size. Okay, and then how could a dilation be represented using symbolic representation? So remember, symbolic representation is when you have the original, let's say xy, and we are going to use a scale factor of 2. That would mean we're going to take our x value and multiply by 2, and our y value and multiply by 2. Now, if we were doing a scale factor that is 1/2, then our symbolic representation would be xy, that goes to half x, half y. Okay, so when we are looking down here, we have the vertices of A, B, and C. So we're going to plot those first. 1, 3, that is letter A. Letter B is at 1, 1. Hold on, I'm going to have to move this A right there. 1, 1 is letter B, and C is at 3, 1, right here. So a very, very tiny triangle here. Okay, so we're going to dilate it by a scale factor of 3. So that means we're going to multiply each and every value by 3. So when we look at our A values, we have 1, 3. So if we multiply this by 3 and this by 3, we end up with 3, 9. That's our new ordered pair. So if I go to the right 3 and up 9, that is where my new A value is going to be. Then my B value is 1, 1. So 1 times 3 is 3. So my new ordered pair will be at 3, 3. 3 and 3, letter B. And then letter C, it is 3, 1, which is the opposite of A. So 3 times 3 is 9. And 3 times 1 is 3. So 9. And you're going to go up 3. Here we go. Oops, I put it at 8, 3. My bad. 9, 3. And these are all our prime values now, so I put those there. And here we go. Here is our new triangle. So complete the following sentences below regarding different types of scale factors. Scale factors blank produce final images that enlarge the image. Okay, so scale factors that are greater than 1. Scale factors that are less than 1 will produce a final image that reduces the pre-image. Symbolic representation on the coordinate plane is given by xy equals kx times ky. K is our scale factor. So in this case, like I said, 5, if that was our scale factor, then it would be 5x, 5y. If our scale factor was 1/2, then it'd be 1/2 x, 1/2 y. Okay, example number 3 here. We have letters A, B, C, and D. So I'm going to go ahead and graph those. -4, +2. Then I have +4, +2. Letter C is at 4, -2. And letter D is at -4, -2. So this makes me a giant rectangle here. Hopefully that didn't mess up anything. All right. Now I'm going to perform a scale factor of 1/2. Okay, so I'm going to take half of each and every number. So if I'm looking at letter A, I have -4, +2. So half of that is going to be -2, and half of 2 is +2. So -2 left 2. And you know what? I just realized that my A and my D are at 3 instead of 4. 4, 2, and 4, -2. There we go. There we go. Sorry about that. A and B. Or no, that was D. Okay, here we go. So -2 left 2, and then up 2. So that is going to be right here. This is A prime. Okay, so for B prime, I'm going to take half of 4, which is 2, and half of 2, which is 1. So right 2, up 1. Oh, I know what I did wrong here. There we go. It should be -2, -1. There we go. A prime. Sorry, I messed that up bad. Okay, and letter C here is at 4, -2. So half of 4 is 2, and half of -2 is -1. So +2, -1, right here, C prime. And D prime, half of -4 is -2, and half of -2 is -1. So -2, -1, D prime. And you should notice that this rectangle now, A, B, C, D prime, ends up fitting inside of that. It is a dilation of 1/2, meaning it is shrinking. Okay, our last part here, example 4, determine the transformation from figure 1 to figure 2. Remember that our type of transformations are translations, which are slides. For reflections, they're flips. There are rotations, which means we're going around in a circle, either clockwise or counterclockwise. And then there is our new one, which is a dilation. Okay, so if I count this line right here that I just did in green, I have 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 across. Here, I only have 1, 2, 3. Okay, now let's see the bottom. It says, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 11, 12. And this is 1, 2, 3, 4. Okay, so if we went from 12 to 4, and then our big one again was 1, 2, 3, 4, 5, 6, 7. Oh, it's just 6. Just kidding, it went here. And then it went down to 1, 2, 3. Oh, it went to 1, 2. This is hard to see where our points are. 1 to 2, if you look at the 2 dots. So, when we make these into fractions, this is essentially 2 over 1, and this is also 2 over 1. Now, if we look at 12 over 4, that reduces to 3 over 1. And if we look at 6 over 2, that also equals 3 over 1. So our scale factor here, we went from big to small, so that means that our scale factor is 1/3. Oops, 1/3. And this was a dilation. Okay, now if we look at letter number 1 and number 2 here, we can see that we have ordered pairs. So if we look at this ordered pair right here, it is at -1, 1, 2, 3, 4. Okay, so that is -1, +4. Well, its counterpart would be over here, and that is at -2 and 1, 2, 3, 4, 8. So when we look at this, we can see -2, -8 is actually 2 times the amount of -1, -4. So in this case, this is again a dilation. But in this case, it is a scale factor of